Hello people, welcome to my first video in a series on building a simulated computer from scratch. Computers are complex machines for various reasons, and if you wanted to say build a graphical operating system from scratch, you'll have a very difficult time. In order to get around that, you can use some of the emulators or simulators out there for say the Z80, the 6502, the DCPU16, chip 8. The problem with these kinds of emulators and simulators is that they have limitations that the computers had in, say, the 60s, 70s, or maybe early 80s. You only have access to a few dozen kilobytes of RAM, low clock speeds, so forth. Wouldn't it be great to have a computer or a simulated computer that's very simple yet has some of the modern conveniences that we have, such as 64-bit addressing and faster clock speeds? So that's the idea behind the Corgi64 project. And what we're going to do in this first video is take a look at setting up our development environment and go over some of the architectural decisions of the Corgi64. So first off, let's actually take a look at some of the design considerations that we put into this system. So the design of the system will be broken up into several different modules or pieces that we will connect together. The first that we'll probably spend most of the time on is the CPU, and the CPU will be connect directly to the memory system that we have. And in fact, the memory, the design of the system is that we'll actually use memory mapped I/O, so all of our I/O and control over our devices will be done through memory, and that's how our CPU will talk to other things. We will also have a graphics and display module which will handle simulation of a monitor as well as handle graphics simulation. Closely along with that, because of implementation considerations, we'll probably put the I/O devices module in the same code base. For those, it will connect to memory and it will deal with things like mice, keyboards, controllers, printers, things of that sort. And then we'll also have a storage system which will interact with the memory and provide all of the functionality of a file system. So instead of having to deal with the file system directly with the CPU, we're actually going to interact with a storage module which will handle all of the details of the file system for us, which is not a new design. There is actually some of the designs back in the 80s which actually had this, but it never quite caught on. So the next thing that we're going to look at is the CPU, since that's what we're going to work on. And the CPU actually has a lot of design considerations taken from the 1970s. So we're only going to have a few registers. In fact, the whole design of the CPU, I looked at lots of different designs from the Z80, the 6502, the DCPU16, chip 8, and the original 8086. And I kind of drew inspiration from all of those, as well as put in some of my own ideas into how this CPU should be put together. There are only 3 general registers that are available. One is the accumulator, which takes care of all of the arithmetic and logical operations. And then we have a couple other general registers, B and C, that allow us to have some temporary storage. Along with that, we'll have the program counter, stack pointer, and a flags register, which will contain all of the major systems in there. Now, none of this is actually set in stone because experience is normally the best teacher, and we'll figure out as we go along what else we may need in this system. It's designed to be a 64-bit system, and the total number of opcodes in our system is actually quite small. 2D, that's something like 50-something opcodes that are available to us. The way that the instructions are designed is they're designed to be 1 byte, which means that we will have only 256 total instructions possible on this simulated machine. And the way that it works is that most of these instructions are designed to work between the registers, which means that we can encode our entire instruction in a single byte, allowing us to have very compact code and hopefully pretty fast code as well. For instructions that require memory addresses and other sorts of addresses and immediate data values, those instructions will be 8 bytes for the data or address value plus the byte for the instruction for a total of 9 bytes. So we'll have a combination of 1 byte and 9 byte instructions. At least that's the plan for right now. And that concludes kind of our overview of the CPU design. So what we're going to do now is we're actually going to work on setting up our development environment to be able to program this sort of thing. And what we're going to do is I'm going to use the C++ language, but in kind of perhaps a surprising turn of events, I'm going to use mostly C idioms for these things, and only a little bit of C++. That's for personal reasons and for kind of philosophical reasons as well. And what we're going to do is this system will also be designed to run on Windows 10, or at least that's what I'm running right now. So I can't guarantee that it'll work on any other systems. You can try yourself to port it to Linux or any other type of system that you want. In fact, the way that it's designed, somebody should be able to port it pretty easily. But for simplicity's sake, I'm not going to add complexity just to run on other architectures or operating systems. We're going to focus on Windows because that is what's running on my machine, and that's where it will run the quickest. I've actually had a little bit of trouble running Linux natively on my machine, and that's mostly due to modern processors and the modern bootloading systems that exist right now. They just make it very difficult if you want to be a Linux user. So we're going to be using Windows. And because we're using Windows, we're going to use the Microsoft Visual Studio C++ compiler. And what you'll want to do is you'll want to navigate to Microsoft's download page for Microsoft Visual Studio Community Edition. That's the edition of the Visual Studio compiler that you can get for free, and it runs all of the .NET languages, F#, C, C++, Visual Basic, and C#, which is their favorite. And what you'll want to do is you'll want to download that, actually, yeah, this button right here, Download Visual Studio Community Edition 2017. Whatever the edition that exists in the future, hopefully it'll still work beyond this 2017 version. You'll want to download it, and then it will give you, once you download it and install it, you'll actually have certain options for what you actually want to install on this machine. Now, I don't know exactly what the minimum things that you want to install for this machine are, because all I want is just a C++ compiler. But I decided to check this Windows Universal Platform Development as well as development with C++. I decided to put both of those in there, and I believe, let's see, for the desktop development. Now the problem with this is there's lots of other checkboxes if you click this thing. So you may have to experiment around a bit to see what you want. Perhaps you want some of these other things, maybe game development with Unity or anything like that, or Linux with C++. All I did is I checked Linux with C++. I checked this desktop development with C++ and Universal Windows Platform Development. Now you can download any of this other stuff. It will be pretty large. Already what I've chosen is somewhere around 3 gigabytes. It can get a lot larger if you're downloading a lot of this other stuff. So choose wisely. If you don't download enough of what you need to get done, you can always get back to this by modifying your installation by going to Add or Remove Programs. Or use the installer that you, or you could just run the installer, the Visual Studio installer that you downloaded, and it will allow you to come back to the screen and modify what you have chosen. So let's, now that you've got Visual Studio installed, the other things that you'll probably want to have are Git, which is a, let's see, let's use Git, which is just a software used for version control for software and other types of documents. You want to download the latest and install it on your machine. I really like using the bash for Git. So if I go in here and I type the git bash command, that allows me to have git bash on here. In fact, if I click this, this will be my version. And git bash is what you can use to, it'll give you some of the Linux command utilities that you might be missing if you don't have Windows Subsystem for Linux installed on your machine. So Git will be what we're using for our version control. So we've got Microsoft Visual Studio, we've got Git. The other things that we'll need to do is we need to be able to set up our system for development, right? We can use Microsoft Visual Studio for our development, but I don't like using it. Integrated development environments are nice sometimes, but they're big, they're memory hogs, and they're kind of slow, I think. So what I'm using is I'm just using a regular text editor, Microsoft Visual Studio Code. If you look for that, Microsoft Visual Studio Code, if you go there, you'll find a link and you'll be able to download that. And Microsoft Visual Studio Code is just a little bit more lightweight text editor. It has ability for all sorts of plugins for syntax highlighting and a lot of other things. I normally use it just for text editing. I don't really add any plugins, but you can do that if you wish. And that's what I'll be using for development, mostly for development here. Another thing that we want to do is you want to be able to set up your folder structure, right? So you want to create a folder, perhaps call it Corgi64 or something like that. And what you'll want to do is perhaps create this hello.cpp file inside of it, and that's what we're going to use to test to see if we have our compiler set up correctly. Now the thing is, in Windows, you don't have access to the C++ compiler by default. You have to actually set that up yourself. And the way that you do that is you need to find where Microsoft Visual Studio was installed on your machine. And what I'm going to do is I'm going to actually show you where it's installed on my machine. I have a data drive with an applications folder, and I created this file here called profile.bat, and what it has inside of it is some instructions that I want to run every time I run my Windows command prompt. So the way that this works is, what I want this to do is I want to set certain paths that I want to be able to have at my command prompt access. So what you'll want to do is you'll want to create, probably, if you want to follow along with me, is on your C drive or something like that, you'll create this folder called applications, and inside of it, it's where I normally put all my applications that I want to use, and you'll create a profile.bat file right here. And what you want to do is you want to turn echo off, so that way it's not talking when it's loading up all this stuff. And then here's what we'll want to do is we want to set our applications path. I have two set up because I have a mapped drive to the W drive as well, but you don't need that. You can just pretty much use this perhaps C applications. I have SFML and things like that set up. You don't really need that. Really, all you need is echo. You need perhaps to set a path like this for perhaps C :/applications. But one of the most important things will be this call function, and it's a function that will call where your Visual Studio is actually located on your machine. Now what I'm going to do is I'm going to actually show you where Visual Studio is loaded on my machine. On your machine it might be somewhere different. It's probably in C program files or C program yeah, it will be on C program files. It won't be in the x64 because they have not been able to port the Microsoft Visual Studio over to a 64-bit compiler, at least not as of January 2018. So on my computer, I have it installed in D, Microsoft Visual Studio 2017 VC. So you'll find this Microsoft Visual Studio folder, and you'll look at for VC, look in auxiliary, and build. And there is a VC varsall.bat. And what this has in it is it has a whole number of things inside of it that sets up the Visual Studio compiler and the include files and everything like that. And that's what you want to call. And so instead of having to call that file from that directory every single time by hand, what we're doing is we're creating a batch file that will call this for us. And because I have 2 drives on my computer and my D drive is much larger, I'm running everything from the D drive. And so what I do is I have echo.off, I have call VC varsall, and this x64 option actually tells me that I want to run my compiler at a 64-bit version because I have a 64-bit computer and that's what I want to run. So D changes me to the D drive, and then CD gives me actually sends me to the right directory where I want to start programming in. So once you have this profile.bat created, you don't have to worry about any of these other things right now. Just do echo, call, and then perhaps if you want to, set up so that you start off in a nice directory instead of starting off at C Windows 32 or something like that. And that will set that up. Now, what we need to do now is set up our command prompt, right? So we want our command prompt to actually run this when we want it to run this profile.bat every time we start up our command prompt file. So what you'll want to do is you'll want to go and find the shortcut for your command prompt, which is probably in, where is it on my system? So mine is in C users, and then my username, app data, roaming, Microsoft, Windows, start menu, programs, system tools, and that's where it is, right? So I have this command prompt file. If it's not there, then you'll want to find the actual command prompt. You can kind of, mine is kind of broken right now, but if you search using the Windows button, you can search for command prompt and right-click it and get the actual command prompt location. But what I do is I have this command prompt shortcut here. You'll want to find that shortcut or find the command prompt itself and create a shortcut on your desktop, so then you can just click on it if you want. And what you'll want to do is for any of those shortcuts that you create, you'll want to go to Properties, and you'll want to go to Advanced, and you want to make sure that you run this as administrator, because you can only run the compiler as the administrator, or at least it makes it much easier. So you want to run as administrator, and you'll want to click OK for that. And then the other thing that you'll want to do is you'll want to run this profile.bat. So in the target for the system, this is actually where the actual exe is for the command prompt is located. It's actually located in whatever your Windows directory is, system32 command.exe. So if you can't find this program anywhere else, you'll find it in your system32 folder, and you'll find command.exe. You'll be able to right-click it and create a shortcut for it. You can put it on your desktop. Then you'll be able to do all of this properties right here. And what you'll want to do is after that exe, you'll want a space, you want a slash and a K, and then you'll want to put the path of your profile.bat. And the profile of the URL of my profile.bat is in D applications profile.bat. And if you do that, then you will have a then that profile.bat will run every single time you open up your command prompt, and it'll make it very easy. You'll be able to use your compiler. The only other thing that is possibly an optional thing that you'll want to do is set a shortcut key. I've set mine to Control-Alt-T, so that way every time I press Control-Alt-T, the command prompt opens up, runs the profile.bat, and goes to my programming directory. So I have lots of things in my programming directory. For this project, I will actually be running it in my CPP, which is my C++ programming file, and then this project is called Corgi64. So that's what we'll be doing. And as you can see, all of my files are in there. So by now, you should have your command prompt set up and running, and what we'll want to do now is we want to test our compiler. We want to test and see if we can actually compile a C++ program, and if we do that, then we will have had our success for today, because we will have set up at least most of everything that we'll need for our development environment, and we'll have successfully compiled. So what you want to do is you want to open up in your Microsoft Visual Studio or Microsoft Visual Studio Code. You can do this thing called File Open Folder, and you can pick any folder you want. I'm running Corgi64, and I open it up, and it will actually open all the files in that folder, and you can see it very easily. So what you'll want to do is you'll want to create a hello.cpp file. In fact, what I'll do just to show how the Visual Studio Code works is I'll delete what I've got, move it to this recycle bin, and I'll create a new file, which is very easy. I just had to click on this new file icon up here. I'm going to call it hello.cpp, and then you'll just want to type in cstandard.io. For the include, you'll have an int main function, and you'll want to return 0, and we'll have a printf hello world. And that will be our program our test program that we'll want to write. The Microsoft Visual Studio allows you to have a terminal. So if you can press Control tilde, it will allow you to run a command prompt or anything like that. But instead of that, what we're going to do is, if you run that terminal, you'll have to figure out how to set up your profile.bat. So instead of that, what we're going to do is we're going to use our regular terminal. So what we'll do is, we're already here. We'll look at our directory. We have our hello.cpp, and the compiler for the Visual Studio compiler is actually called CL. So if you type in CL and then the name of the file that you want to compile, and you hit enter, it will spit out all this stuff that tells you, hopefully, that you created an object file and an hello.exe. So now if we look at our directory, we have a hello.cpp, which we created, which is only 80 bytes. We have an hello.exe, which is 113 kilobytes, and we have a hello.object file. If you're successful, then you should have not gotten, this is what you should have gotten. So if we run this hello.exe, then we should get hello world. And if you didn't do that, then perhaps you don't have your compiler set up right, or you need to do some troubleshooting yourself, maybe do some searching on a web browser, and figure out what you need to get set up properly. But if all that went well, then we'll be ready for our next video to actually start working on our implementation of our CPU. Thank you for watching, everybody. Till next time.